Hi everyone, welcome back to my channel. In today's video, we are going to talk about implicit differentiation. So previously I did a video on introduction to differentiation, and that's where we learned how to find basic derivatives of a function. Basically, we have a function y equals to f of x. For example, y equals to x squared, for example. The derivative of that would be 2x, right? And then we also learned product rule and quotient rule. So remember that product rule is u prime times v plus v prime u. And quotient rule was u prime v minus v prime u divided by v squared. And these are really helpful because throughout the course of finding derivatives, these rules are important because it comes up often and it's used many times. And today's video, instead of focusing on that, we're going to do implicit differentiation, where, as you can see these examples shown here, we can see that y is not by itself. And so usually when we want to find a derivative, it is in terms of y. dy by dx is with respect to x. So therefore, when we find these, oftentimes we will isolate y so that it's y equals to a function, and then find a derivative in terms of x. But here, on the other hand, y is not by itself. And if we were to solve for y and basically leave y alone, we would get something like 25 minus x squared, and then y would be square root of the whole function. And that is something that's possible to do, but sometimes instead of doing this method, a better way to do it is using implicit differentiation because it's simpler. So when it comes to implicit differentiation, what we want to do is, when we want to find the derivative of something like this expression right here, we want to just basically find the derivative of each individual values. And remember that every time we find the derivative of y, we always must multiply by dy by dx. So what I mean is, here in this example, we have x squared plus y squared equals to 25. So first off, what is the derivative of x squared? It is 2x, and y squared is going to be 2y. But because this is not in terms of x, we must always multiply by dy by dx when we find the derivative of y. And the derivative of 25 is 0 because 25 is a constant number. So now what we want to do is, the question asks to find dy by dx. And basically what we want to do is basically just isolate dy by dx so that it is on its own side. So we have 2y times dy by dx, and let's move this to the other side. So it's going to be equals to negative 2x, and we want to isolate dy by dx, so therefore we would divide it by 2y. And to simplify that, we get dy by dx equals to negative x over y. So that is our derivative of this expression. And very simple, basically. Here we basically just found a derivative, and we didn't need to isolate y or anything like that, but we basically just needed to always multiply by dy by dx whenever we find the derivative of y. So there you have it. And now let's try another question. Again, same pattern. The derivative of x squared is 2x. And remember here, this is x times y, so that is the product rule. So we want to go back and use this rule. Because it is multiplication, we have to use this rule. So let x be u and y be v. So the derivative of x would be 1 times y. And in this case, we have the y value, but we do not need to multiply by dy by dx because that's not the derivative of y. We're finding the derivative of x only. And then now we have the derivative of y times x. So x times the derivative of y is 1, And because we found the derivative of y, we must multiply by dy by dx. And for derivative is 0. So now what we want to do is isolate dy by dx. So let's simplify the function first. So we get something like that. And next step we could do is move these two to the other side. So negative 2x minus y equals to dy by dx times x. And to get dy by dx, we divide it by x. And there you have it. That is our derivative of this expression. And last but not least, let's try this problem. A little more challenging, but the idea or the concept is the same. So here we have x over y. We want to find the derivative of that. And because it's division, we must use the quotient rule. So this is going to be u, and this is going to be v. Remember, it has to be u prime v minus v prime u divided by v squared. So then, now we want to find the derivative of x, which is just 1 times y. And again, no need to multiply dy by dx yet because I haven't found the derivative of y yet. Minus x and times the derivative of y, which is 1. And because we found the derivative of y, which is 1, we must multiply it by dy by dx. And the whole expression divided by v squared, y squared. Plus derivative of y is 1. And again, we must multiply it by dy by dx equals to 0. And so now what we want to do is simplify it so that we have dy by dx alone. So if I were to simplify it, let's move this to the other side first. So maybe negative dy by dx equals to y minus x times dy by dx over y squared. Let's move this to the other side. So negative dy by dx multiplied by y squared, we get y minus x times dy by dx. And so now let's also move this to the other side. So negative dy by dx y squared plus x times dy by dx equals to y. And so now our next step is we can see that the dy by dx, we can factor it out. So we can have dy by dx by itself multiplied by negative y squared plus x, and we factored it. So if you want to double check, you expand it, it should be the same as this one, equals to y. So now, easy, we can just divide both sides by negative y squared plus x, and there you have it. We have dy by dx equals to y over negative y squared plus x. So I hope this video helps. You can always use implicit differentiation when you have expressions like these where y is not by itself. And it's really useful because, as you can see, the process is not too hard. But sometimes people often make careless mistake because they forget to multiply by dy by dx. So the main takeaway is when you do implicit differentiation, remember to always multiply by dy by dx when you find the derivative of y. But when you find the derivative of x, on the other hand, like x squared is equal to 2x for the derivative, you do not need to multiply by dy by dx because it's already in terms of x. But if it's in terms of y, again, dy by dx, dy by dx, dy by dx. Yeah. So I hope this video helps, and I'll see you guys next time.